Both the Laser Edit Profiler control application and the Ceramage application use Deposit as their data storage, which is an open source graph database focused on scientific data collection. Deposit is available to download and even modify if you like from its website on GitHub. And there is also a graphical user interface which can be downloaded from this website and installed under Windows. There's a Windows executable, but it should be also possible to install it under other operating systems. It's written in the Python programming language. So before we delve into the practical aspects of Deposit, let's have a look at some of the theoretical concepts behind it. So, as mentioned, Deposit is a graph database. So the data is stored in the form of nodes, which are connected by edges, and both those nodes and the edges can be labeled. This is a general concept of graph databases. Specific to Deposit is the concept that the basic entity is an object, which represents an observed thing which exists in our world. It can be a find, it can be a pit that we have excavated, it could be some sample that we have collected or just recorded. And this is an unlabeled node, so there is no other information or name or anything like that associated with an object. And in an SQL database, this would be a row without any columns. Another type of nodes in the Deposit format is a class, which is a labeled node, and it represents a category of objects. So if we say this object is a pit, then the pit would be a class of this object. So in an SQL database, this would correspond to the concept of a table. So we could have a table of bits or a table of samples. Now, this type of relationship of an object belonging to a class is expressed by a relation or the edge between an object node and a class node. And the type of this relationship is member of. So the object is a member of the class, and this class has a label. It's named. Now, another concept are relations. So these are labeled edges between objects and classes. So it can be between two objects, or between two classes, or between an object and a class. And relations can be weight. A corresponding concept in the SQL world would be a many-to-many relationships. So we can have arbitrary number of relationships between objects and classes. So apart from the relationship is labeled, so it has a name, and it can also have a weight, so which can represent the intensity or degree of this relation. Apart from that, the objects can have descriptors, which are a way to assign specific properties or attributes to objects. Descriptors can be individual or shared. An individual descriptor is a relation between a class and an object, and it represents the value of a certain class assigned to an object. And in an SQL database, this would correspond to a column or an attribute in a table. So, for example, if we want to record the length of a specific find, then we have the class length, which is a certain category of a property that an object can have, and we connect it by a relation to the object, and the label of this relation would be 120 millimeters, which represents the value of the length. And this object also has a relation to the class find, which is a member of type of relation. So the object is this means that the object has the class, or is in the category find. Another type are shared descriptors, which are useful if we have some descriptor, some attribute that we would like to assign to multiple objects. For example, like a material. So in our SQL database, this would be the typical one-to-many relationship. In this rather more complex scheme, it's expressed as an object having the relation this descriptor. So this object, which is the member of the class find, has a relation descriptor to another object. So this object represents the shared descriptor of this object, and this descriptor object is a member of the class material. So it represents material, and it itself has a descriptor named, which has the value stone. So this means that this object is described by a material with the name stone. Now let's have a look how we can use this in practice. So let's say we want to add information about areas and features where the samples have been found to our LAP database. So let's open the LAP application, open a database of finds. So we have this sample database of ceramic finds here, and we want to add information about features and areas. So the first thing to do is open the deposit database. So this opens the user interface for the backend, for the database itself. And here on the left, you see a list of classes and their descriptors. So these are classes which are created by the LAP application when the drawings are created, and all the information that's necessary to create the drawings is stored in this data structure. We can also open the relations graph here to visualize those relations. So these are classes, and these are relations between those classes. And we want to add some two more classes to this structure. That would be the area and feature class. So let's first create the area class. I just click add class here, name it area, and a feature class. Classes have already appeared here. They have no relations yet, but I want to specify a relation that the area contains the feature. So I just click here on add relation, type in contains, and click on the feature class. This will create a relation between them, and also a relation that the feature contains the sample. It's the sample. Okay, so this is the database structure. Another thing is that we need some descriptors. So each area and each feature has to have at least a name. So I click here on the area class, and I click on add descriptor and type in the name, and the same for the feature class. Okay, so that's it for the backend. And now I can almost start entering the data, but another thing I need here is you can see here's a list of descriptors. Right now there's only the sample ID. So if I open a drawing here, then I don't need this. Then I just see the sample ID here. Now I want to also be able to enter the area and feature information here. So I go to Data, Edit Descriptors, and I can add my custom descriptors. These are the required, the default LAP descriptors. And I click Add, name this feature, and I can specify the type of the descriptor. So the sample ID is just a line edit. This is good for descriptors that are unique for each sample, but we want something like a dictionary, a lookup where we can reuse the same feature with several samples. So we use a combo box, which will present a drop down with the feature numbers. And here we have to specify the relation to the target class. So we have to specify how the feature relates to the sample. So normally this would be feature contains sample, but we also have to specify the descriptor in the feature class where the name of the feature will be recorded. So that would be feature name. So we have to reverse this relation here. So it will be sample, which is already established here in the previous row, is contained in, and that I can write this by using the tilde character, and contains, this means a reverse relation, contains feature. So is contained in feature, and name would be the descriptor. And I can add the area descriptor, again as a combo box. And here I have already established a link to from the sample to the feature, and now I need a link from the feature to the area. So feature is contained in area name. Click OK. You see the additional fields have appeared here. I can save this just in case. And now I can enter the feature and the area name. So this the sample numbers here are they already contain this information. So I can just copy. This would be the feature number, and this would be the area number in this case. Oops. And store it. And you see here in the browser already the feature name and the area name are shown next to the sample, and I can do this with all the other samples. The application now offers me to load different settings because the database was stored with a different set of descriptors. So if I would click OK here, these descriptors here would disappear. So I don't want that. So I just click cancel, leave it as it is, and again store feature number and the area number, and so on for all the other finds. Area number. So now when I open the drawing, automatically it loads also this information here. And also if I open it in Deposit in the backend, and I open the sample class here, it will be shown as a table similar to the browser interface. And if I click an object, this would be an object. These are the individual descriptors here, and I can also look at the relations here, and you can already see here there's a link to the feature in which the find is contained. I can open it like this, and with this feature there's a link to the area in which the feature is contained. So this is a way to record additional information with the finds. You can see since I have used combo boxes here, there's a drop down. So if this descriptor could be, for example, for material, so I could, as I enter more and more data, there would be a drop down of all the different types of materials that I have recorded, and so on. So I can store this and save the database. And if I would like, I can also, there's a possibility to possibility to export the descriptors here as a text file. And then they can be then imported. So if you want to move your database elsewhere, or create a new database, a blank one, but with already these descriptors specified, you could just import all this structure and continue working on it. So this concludes the basic introduction to working with the deposit database.